The ambiguous case, algebra 2 trigonometry regions. The ambiguous case comes from the law of sines when you use the law of sines formula to solve for an angle. The law of sines formula, as we know from a previous lecture, is A over sine A equals B over sine B and C over sine B, and really any letter side over the so any side over sine of its opposite angle, right? Any side over the sine of its opposite angle. That's what the law of sines is given to us as, and in the previous lecture we used it to cross multiply and solve for a side, solve for one of these. So you were given two angles, and you were also given a side across from one of the angles, and you were finding the other side by cross multiplying and using our calculators and everything. But the problem exists when you do law of sines to find an angle. Like in this case here, we have side D, side E, angle D. Now again, you could always recognize a law of sines problem when you have that complete set of a side and angle opposite it. So D and D, side D, angle D. So they will certainly go together. So let me change colors here to green. This would be 5 over sine of its opposite angle 32. So side D over sine D. And then I have side E here, and so that would be 8, but I do not have angle E. And so I'll just put it over sine of angle E for now. And now the problem doesn't really tell you to use law of sines and stuff like that. These questions are often worded very similar. It says how many triangles or how many distinct, that's a key word there, how many distinct triangles can be drawn under this given information. So if you ever see that phrasing, this is an ambiguous law of sines question. And you got to cross multiply to get there. But again, what's different is we're trying to use the law of sines to find an angle here as opposed to a side. And the reason why it's ambiguous is because when we cross multiply here, we're going to end up getting a value for sine E, not angle E. But how do we turn sine E into angle E? Is we use the inverse function of sine. And so we're going to type into our calculator second sine. But remember that for sine, if you remember from the ASTC we did a couple weeks back, that sine is positive in quadrant 1, but it's also in quadrant 2. So like, for example, if you knew that sine of theta equals 1/2, what's angle theta? Well, the answer is ambiguous, meaning we're not really sure. It's ambiguous because I know that sine of 30, move this, sine of 30 equals 1/2. Come on, tablet, wake up. Sine of 30 equals 1/2. But that's not the only angle. Since sine is also positive in quadrant 2, sine of 150, which is 30 degrees from the x-axis over here, is also 1/2. So since sine 30 is 1/2 and sine 150 is also 1/2, just saying that sine theta equals 1/2 is ambiguous. We're not really sure then if the angle is 30 degrees. Sorry. Hold on, let me fix that. So we're not really sure if the angle is 30 degrees or 150 degrees. And my tablet's acting up, so I'm going to have to use the mouse, and my handwriting is going to be a little sloppy. So we don't know if it's 30 or 150, and saying that sine theta is 1/2, well, sine 30 and sine 150, because remember 30 is 30 degrees from the x-axis, and 150 is also 30 degrees from the x-axis, but this x-axis, which would be considered 180. So it's ambiguous when you do this, and you're not really sure what quadrant you're in. So that's what the background of the ambiguous case is, that you set up a law of sines, and we're going to cross multiply and solve for sine E. But in the end, we're not really going to be sure what quadrant angle E is, so we have to test both quadrants 1 and 2. We're not going to bother testing 3 and 4 because those are angles greater than 180, and we are talking about triangle angles, and triangle angles can't be more than 180. So that's why we only need to test 2 quadrants here. But we do need to test them both. So let me just pause for 1 second. I need to try to fix my tablet up. 1 second. Okay, we're back. So if I cross multiply here, I have 5 times sine E, which is just going to be 5 sine E. And then I have 8 times sine 32, which let our calculator do for us. It's going to be a decimal. So it would be 8 times sine 32, 8 times sine 32, and that equals 4.239354100, so on, so on, so on. I'm just going to express it right now as 8 sine 32. And what I do with that number is then to get sine E alone, I divide by 5. And so I'm going to divide by 5. And sine E is approximately, because it's going to be some decimal, is taking this number divided by 5. So if you do 8 times sine 32 divided by 5, you get sine E, which is 0.8478. So 8478, 0.8478, and a bunch of other numbers. But how is this helping me? I want angle E. So what I then need to do here is I need to turn this into angle E. But I'm actually going to get 2 possibilities. I'm going to get a quadrant 1 angle E and a quadrant 2 angle E. And the way I'm going to do that is I'm going to do inverse sine, which is second sine, and I want this whole number, so I'm going to grab it as second answer. I'm not going to retype it because I won't get all of it. So you cross multiply like you did in law of sines, but then you got to do second sine, second answer to solve for the angle part of it, and you're going to get 57.9808. Doesn't matter what it is. We can round this. Let's round it to just be 58 degrees. And so that's going to be one of my angle E's, is 58 degrees. But my other, and so that's a quadrant 1 answer right there, 58 degrees. I need to know what its quadrant 2 answer is. And the good thing about quadrants 1 and 2 when it comes to trig is that these angles are supplementary. So if I have one, I could find the other by doing 180 minus that 58, or I'll do second answer here, and that'll be 122. And so that's my other possible angle E. It's 122. And what's tough is the calculator only gives you one. Calculator just kind of takes its best guess at what quadrant you're in, but we know better than that. So whenever we do inverse functions in our calculator, we know that there's usually going to be 2 angles there. So you set up law of sines like you always have, or always, I mean, we only learned it probably a day ago, but you set up law of sines, cross multiply, but cross multiplying only gets you sine E. To turn it into angle E, you have to do inverse function in your calculator. So second sine, second answer, that'll get you one of them. Do 180 minus it to get the other. So let me put that up there too. So this would be 180 minus 58 is how we're getting the 132. All right, so how do we tell which angle E is it? And that's the stuff that makes it ambiguous. Sometimes it's both, sometimes it's just one of them. Well, we need to test them, and the way we test them is by using the angle we already have. We know that angle D equals 32 degrees, and that is a guarantee. We know angle D is definitely 32 degrees. How do we know that? The problem tells us that. It's definitely 32 degrees. And so what's the third angle in each case? This is triangle DEF. We have a potential E, a definite D. What would angle F be in this scenario? Well, we have 58 and 32. Well, what we know about triangles is that the 3 angles add to 180. So if you do 180 minus the 2 that you have, minus 32 and minus 58, that will get you your next angle, which is 90. And how about scenario 2? What if E is 122 and D is 32? Well, if you do 180 minus those, 180 minus 122 and minus 32, we get that it is 26 degrees. And so what we see here is we end up with 2 plausible triangles. This could be triangle DEF, or this could be triangle DEF. So how many distinct triangles can be drawn? The answer is 2. They both work. See, what you're going to see in some of these problems is that this second scenario, like if this angle was, say, 150, well, 150 plus 32 is 182. That doesn't work out. See, I don't even really care what these angle Fs are. What I really care about is basically, is there room for it? Can you make an angle with these two angles and find a third? And so if these two angles add to more than 180, then this won't work, and the answer is only this one works. And then sometimes there's going to be some cases where the answer is 0. Sometimes it's 1, sometimes it's 2, sometimes it's 0. It is never, ever going to be 3 because, like we said, we're only working in 2 quadrants. So the answer is either 1, 2, or 0, so never choose 3, even if you have to guess. Never choose 3 here for these questions. When is it going to be 0? It's 0 sometimes that if you cross multiply here, see how sine E was 0.8478? That's an okay sine value, but if it was 1.84, then none of this would work out and the answer would be 0. The reason is sine can never be more than 1 because sine is opposite over hypotenuse, and the hypotenuse has to be greater than the opposite. So when you have a fraction where the top is smaller than the bottom, it's always less than 1. So if you ever cross multiply and it says sine E is 1 point something or 2 point something, automatically the answer is going to be 0. That's the case that usually gets 0. Let's look at one more example here. Let me just get a time check, see how we're doing. It's been, wow, 11 and a half minutes already. All right, so I don't want to go too long on this, so I'll stop it here. Let me just give you a quick 2-second recap. Set up your law of sines with what you have. Cross multiply to find sine E. Second sine, second answer to get angle E. Supplementary with that gets you the other angle E. Test them with the angle you have. See if you can find a potential third. If you can, they work. If you can't, they don't. We'll practice a lot more of this tomorrow. Sorry the video ran a little bit late.